Welcome to 100% here. So we are going to discuss in the unit composite materials and structures. Micromechanics and macromechanics is the unit. Here today we are going to discuss about the macromechanics approach in the materials, especially in the composites. So in today's class, macromechanics and then what are the key concepts involved in the macromechanics, as well as macromechanical properties, then macromechanical theories and applications. So these are all things we are going to discuss in today's class. So what is macromechanics? We already studied micromechanics, and now we are going to move on to macromechanics. So we are going to study the behavior of the composite materials at the macroscopic level or macroscopic scale. We are going to examine the overall response of the composite to the external loads, as well as we are going to focus on the elastic, plastic, and failure behavior of composites. So these are all things in the macromechanics. The macroscopic level, we are going to analyze the behavior of the composite materials as well as the overall response of the composite to the external loads, focusing the elastic, plastic, and the failure of failure behavior of the composites. Then we can move on to the key concepts in the macromechanics. One is stress strain behavior. It describes the relationship between the stress and strain in the composites. As well as Hooke's law we studied, then we can move on to yield point, ultimate stress. Then after that, how it going to be have a fracture. Then elastic properties defines the elastic behavior of the composites, including Young's modulus, Poisson's ratio, and shear modulus. Then plastic properties comes in picture in the macroscopic level. It describes the behavior of the composites, including yield strength, ultimate strength, and strain hardening. But in micro mechanics, it will not be available. Up to the elastic limit only we have focused. In macroscopic level, the plastic deformation will be included. So it goes beyond the elastic limit. So that yield strength, ultimate strength, and strain hardening, all the things here are going to be focused. Then failure criteria, it predicts the failure of the composites under various loading conditions. So these are the main key concepts in the macroscopic level. And what are the mechanical properties? That is macromechanical properties. One is tensile properties, compressive properties, then shear properties, flexural properties. So tensile properties measures the response of the composites to tensile loading. Tensile load means the elongation will be there. You are going to stretch the material, composite materials, so that whatever the tensile strength we can have for the given composite material, whether can withstand a more amount of strength or not, as well as compressive properties also. We are going to apply compressive load so that the deformation will be, shrinkage will be there. Here also the compressive strength we are going to assess. And the shear properties. So shearing loading, shear loading. That means we are going to apply in the same magnitude in the opposite directions. Like that, if you apply, how much amount of shear load it can withstand. That is, we can analyze. And the flexural properties, here it measures the response of the composites to flexural loading. Then macro level, what are the mechanical theories are available? One is classical laminate theory. Whenever macro level comes into picture, laminates, that word, it will come. So classical laminate theory, it predicts the behavior of laminated composites under various loading conditions. Then first order shear deformation theory also comes into picture. It accounts for shear deformation in laminated composites. And finally, one more thing is there higher order theories. It includes the higher order terms to improve the accuracy in predicting the composite behavior. So higher order theory, generally it is used for getting the more amount of accuracy level, so that the composite behavior, how it deforms the, how it affects the plastic as well as material properties of the composites. Then let's move on to the applications. We have structural analysis. Here, the structural analysis uses the macro mechanics to predict the behavior of composite structures under various loading conditions. Then design optimization is also studied in the micro level. So macro level, it has been assessed and analyzed to optimize the composite design for specific applications. Then failure protection is a very important phenomena, how much strength it can withstand. Accordingly, you have to utilize the macro mechanics to predict the failure of composite structures under various loading conditions. Accordingly, we have to design. So these are all the applications. So by understanding these macro mechanics in composites, we can predict the behavior of composite materials and structures and optimize the design and ensure the safe and reliable performance. And we can elaborately we can study that macro mechanics. Generally, it examines the elastic, plastic, and the failure behavior of the composite, including the effects of fiber orientation, volume fraction, and the matrix properties. Then key concepts already studied. Here we can go for yield strength, ultimate strength, strain hardening. Those plastic properties we have to describe here for macro level analysis. As well as failure criteria, it also predicts the failure of the composites under various loading conditions, including maximum stress criterion, how much stress it can withstand. Then maximum strain criterion also, as well as on failure theory called Phi criterion also, how much plastic deformation can be there. Accordingly, failure theory can be also analyzed by using macromechanics approach. Then mechanical properties already studied, tensile properties. In these tensile properties, what are the things or the parameters available? Tensile strength, then tensile modulus. That is, tensile modulus is here, we are using Young's modulus only. Then tensile strain also. Then compressive properties means the same compressive strength, then compressive modulus. Here also Young's modulus only we are going to have both the tensile and the compressive. We are having the bending strength only. Tensile modulus as well as compressive modulus both are same only. Then compressive strain due to the failure. First the failure we are going to study. Then shear properties, it measures the response of the composites to shear loading. That is shear strength, how much shearing effect will be there so that it can withstand the shear load, and shear modulus and shear strength to failure. Those things we have to focus. Then macroscopic level, it is very important to study on that. Then flexural properties also, it measures the response of the composites to flexural loading. That is flexural ring, flexural strength, flexural modulus, flexural strain to the failure. So those things we have to study about those things. Like mechanical theory, what we have told, like classical mechanical theory. Then here we have an assumption like a linear elastic behavior, perfect bonding between layers. These are very important when focusing on the classical laminate theory. Linear elastic behavior as well as the perfect bonding between layers. Then first order shear deformation theory accounts for shear deformation in the laminate composites, including the shear strain and the shear stress. Then first order theory, generally it is used to have a more amount of accuracy level to predict the composite behavior, including the second order shear deformation theory as well as third order shear deformation theory. But we are using only this first order shear deformation theory. Then application point of view, structural analysis, that is use of macro mechanics to predict the behavior of composite structures under various loading conditions, including beams, plates, cells. These are the important composite structures. We have to analyze the prediction of behavior of the composite structures. Then design optimization also very important to optimize the composite design for specific applications, including minimizing the weight, maximizing the stiffness, and optimizing the fiber orientation. These are the very important for design optimization. Then failure prediction. It utilizes the macromechanics approach to predict the failure of composite structures under various loading conditions, including predicting the failure loads. So at which load it can the composite material can go for failure stage, as well as the material can be chosen for particular applications. And identify the failure modes, then optimizing the design for failure resistance. Those are things we have to discuss in this class. So once again, I will just summarize what is the macro mechanics, what are the key concepts in this, what are the macro mechanical properties, and what are the mechanical theories for macroscopic level, what are the applications. So those things we have discussed in this topic in this class. So that's all in this video. We can move on to another topic in the next class. Thank you for watching this video. Thank you one and all.